yesterday, where we had 40-mile-an-hour winds, gusting even higher than that. But looks fantastic. Once again, this is the last transit of Venus that we're going to see for 105 years. The next one's going to occur in 2117. So in 105 years, we'll, if you're around, we'll have to actually move into our robot bodies to see that one, most of us. And 8 years after that, in 2125, there'll be yet another transit of Venus, and that will be that 8-year pair. This 8-year pair, 2004 and 2012, follows the previous one by 122 years, which occurred in 1874 and 1882. The 1882 one was interesting because that was the first transit of Venus that was actually photographed. That was photographed up at Lick Observatory near San Jose, California. And if you, on our site, you can look at the timeline on our site and you can get to an animation made from the photographic plates of that transit of Venus. You can see an animation from those 120, actually it's 134 years old, actually be 140 years. Long time. And we're almost, not quite halfway, towards fourth contact in the visible light view. And a little bit further, a little bit less than halfway actually, in the further away from fourth. This is of Mercury. Mercury also passes between the Earth and the Sun. And it does that actually more often than we get transits of Venus. Transits of Mercury happen in pairs about 13 or 33 years apart. The next one that we're going to see is in 2016, so only a few years from now. 4 years from now, we'll be able to, somewhere on the Earth, you'll be able to see a transit of Mercury. And then 3 years later, 2019, there'll be another transit of Mercury. So you can see they're much more frequent. Then the next one after that is 2032 and 2039. It's very rare to see a transit of Mercury and a transit of Venus within a single year. It has happened. In 1631 and 1769, there were transits of both Mercury and Venus in the same year. Unfortunately, the next time that's going to happen for us is quite far off, 2611, and again at 2854, and once more 976. So that's a pretty rare event. You may have noticed that this transit of Venus did not travel across the entire diameter of the Sun. It made a chord across the Sun, north of the equator of the Sun, and that to get a central eclipse, a central transit of the Sun, that doesn't happen very often. The next time that's going to happen, write this. You have your calendars open. Write this down: July 11th, 5900 AD. July 11th, 5900 AD. That's the next time there's going to be a central transit of Venus. Our transit here today lasted about 6.5 hours. The central transit of Venus, since it travels across more of the Sun's disk, will be a little bit longer. It'll last 8 hours. Everyone got that on their calendar? know that we're planning on going to other planets, you can only see transits of planets that are inside your orbit. So for the Earth, only Mercury and Venus can get between the Earth and the Sun. But if you're on an outer planet, then you can see transits of, say, the Earth. For instance, from Mars. If you're on Mars, there actually was a transit of the Earth across the Sun in 1984. But the next time that will happen is in 100 years later, in 2084. Again, on your calendar, 2084, November 10th, Mars. Looks like we're about halfway exited in our hydrogen alpha view. And we're a little past halfway in our visible view. And it's even a little further in our calcium view. Because we're looking from Jupiter. If you were viewing from Jupiter, of course you can't stand on Jupiter because Jupiter is a gas giant planet, but if you could, there was a transit of the Earth across the Sun in 1996 and 1984, 1972, 2008. It looks like the next one will be in 2014, so only in 2 years. So you have 2 years to get to Jupiter, which may be a problem in and of itself, let alone standing on its surface. And we're approaching fourth contact here. Which, if you look at the National Solar Observatory's website for Mauna Loa, is predicted for 4:44 UTC. So we're about we're at 4:37 right now. So we have about 6 or 7 minutes to go. And here's our hydrogen alpha view. You'll be the last one to make fourth contact, again, because you're looking at the hydrogen sun. It looks a little bigger because we're looking at the outer atmosphere of the sun. You can see that little prominence below the sun. It's getting a little harder to see now. Maybe we can pump up the gain on our camera a little bit and bring that out. There we go. That'll help us see the fourth contact here, too. Took a lot of people to bring this transit to you. Bill Dean provided all of our telescopes and magnetic images, provided all of our video and audio equipment, and they've been riding on these images all 6.5 hours. The NOAA Atmospheric Observatory provided us with the location and the data, and a lot of help to get that data flowing. And the Exploratorium, of course, provided the rest of us to help you see the transit. We're looking at the visible light image right here. We're getting very close to fourth contact. Again, kind of hard to see. It's kind of hard to judge when Venus is completely off the disk of the sun. Predicted for about 4 minutes from now. I think we should take one last look at our calcium view, because I don't think it's going to be much use after this. There you can just see it. It's pretty sharp, though. It's a nice sharp view, so you can just barely see a notch. Venus taking a little notch out of the solar disk at about 2:30 on the solar disk there. Hydrogen view. About 3.5 minutes. Probably that's from the visible image. Let's check that out. There we go. Just a small notch now. We'll first see the visible image leave the sun on the visible sun, and then we'll probably be able to switch over to the hydrogen alpha version of the image and get to see a fourth transit again. I'm told that visually, if you have a safe solar filter, you can no longer see anything. I have some folks outside here just using their naked eyes to view this. It was a beautiful naked eye thing. You could actually see the transit of Venus if you had the proper filtering. Don't do it without the proper filtering. Never look at the sun without proper filtering, or if you're using optics, knowing exactly what you're doing, projecting the sun. Galileo was the first person to see sunspots, except he damaged his vision and was almost blind for the rest of his life. You still see a little notch there. Because of the refraction of the atmosphere, this is going to be hard to judge. Barely see it still. So maybe a minute or two left. Becoming increasingly hard to see with the distortion due to the atmosphere, but the atmosphere makes temporary dents in the edge of the sun, and Venus is making kind of a permanent dent there, so we can still see it just barely. And if we're going to keep on our visible sun for just another minute or so, because I think we're going to be out pretty quick here. I think I can see, because if when we move away, we're going to move to the hydrogen alpha view, and then we'll maybe be able to see fourth contact all over again, because the hydrogen alpha view, again, you're looking at the outer atmosphere of the sun. I think that we may have seen the end of the transit in visible light. Let's let it go for another 15 seconds or so. I don't think I can detect it anywhere. So let's switch over to hydrogen alpha view. You can still barely see a dent in the sun there. Subtle, but it's there. And we may see our second, fourth contact. And that looks like it might take just a minute or so to leave the disk. Gets harder and harder to tell, but I think we're still seeing it. Just barely, though. I think it may have left the disk at this point. So that marks the end